Hi, 8th grade. Okay, so welcome to day 2 of week 5, April 21st. I'm going to show you what you're responsible for today. So I'm going to click on the classwork tab. I'm going to go down to day 2. Let's go through the lesson so that you guys understand what you're doing today. So today we are focusing still on graphing solutions, but we're going to focus on when we are given equations that are not in y equals mx plus b form, which is also known as slope-intercept. So you have a warm-up where it's just identifying the solution. Remember, the solution is always going to be the point of intersection. If you go to the next slide, the answer is there for you to check your work. And then we go into what I just mentioned. So in order to graph when given standard form, you need to manipulate the equations so that you isolate y and they're in the form of y equals mx plus b. So if we're given these two equations, that's what we're going to do. I'm going to remind you that you have standard form, which is in that format, ax plus by equals c, and we want to manipulate them to be in slope-intercept form, which is y equals mx plus b. So we're going to do that by doing our inverse operations to get y alone. So if I look at the first equation, my goal is to isolate this y. So I know that I have to move this x. So in order to move this x over here, I'm going to do the inverse of it and subtract x. So now x minus x will cancel out, which is what I want because I'm getting y by itself. And then over here, these are not like terms, so I just bring down negative x plus 8. And now we're in slope-intercept form. Remember, there is an imaginary 1 here, so this slope is actually negative 1. Okay, so that equation's done pretty quick. Then we move over to the second one. We have 2x plus 1y equals 11. Again, our goal is to isolate y. So we're going to do the inverse operations to get that alone. So I'm going to inverse 2x by subtracting 2x from both sides. Okay, so these two x's will cancel out. I'll be left with 1y equals, these two are not like terms, so I'm going to bring them down, negative 2x plus 11. And then we have 1y left, so I'm going to divide by 1, which really doesn't change anything, but I'm just showing you how to get rid of that coefficient. And we'll be left with y equals negative 2 divided by 1 is negative 2, x, 11 divided by 1 is 11. So again, we're in our slope-intercept form. So now that we have both of these equations in slope-intercept form, now we can graph them using what we did yesterday. Okay, so I'm going to take my graph now. And these are the equations we just manipulated and came up with. So if I look at the first one, we see that our slope is negative 1, like I showed you before. So it's going to be negative 1 over 1. Remember, when it's negative 1, we go down 1 to the right 1. Some of you had trouble with that yesterday, so I'm glad that this came up again. And our b is going to be 0, 8, because that is the intercept in the equation. So let's graph that one first. I'm going to go to 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's going to be my intercepts, my beginning point. And then I go down 1 to the right 1. So down 1 to the right 1. And I keep going. Okay? And then remember, you want to connect arrows and then put your equation somewhere near the line. It could be the standard form or the slope-intercept form. They both mean the same thing. Okay? And now I'm going to go to the second equation. Our slope is negative 2, so that means it's negative 2 over 1. So this time we're going to go down 2 and to the right 1. And we're going to begin at 0, 11, because our intercept is 11. So I'm going to count up to 11, make my point, and I'm going to move down 2 to the right 1. So down 1, 2 to the right 1. And I keep doing that pattern. Down 2 to the right 1. Down 2 to the right 1. There's our solution. Down 2 to the right 1. And so on. Okay, so we connect our points, put arrows, write the equation, and then we will identify our solution. So our solution is going to be this point here, which is the intersection point. You circle it, and then you identify what that coordinate is. So that coordinate would be 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. Okay, so this part should be pretty simple for you guys since we already did this lesson yesterday. I don't see you guys having trouble with that. What I really want you to focus on is what I just walked you through, is taking it from standard form and then writing it in slope-intercept. Standard form, writing it in slope-intercept. And all you're doing is just manipulating the equation to isolate that y by doing inverses. Okay, so you'll see that answer is the following answer. I have that here, taking you step by step. Same answer as what we just came up with. Then there's another example for you to try. Something interesting happens on this one. So I walk you through how to manipulate it. The second equation, only the second equation is not in y equals mx plus b. The first equation is, so you only have to do it for one equation. And in this one, when you manipulate it, you get y equals 2x minus 1, which is the same equation as the top one. So when we graph those two equations, does anyone remember how many solutions that will be if they're the same line? So I model it for you to follow. There's the first line. There's the second line. What do you notice? They're the same line, so there would be infinitely many solutions. Okay? So then there's two more for you to try on your own, and then there's a practice. So this is a printout available in Google Classroom. The same rules apply as yesterday. There are the different options for you to complete this. Some of you are able to manipulate a PDF and do it digitally, which is great. Some of you are printing it and sending me a picture. Some of you are texting me. Some of you are sending it through Instagram. Whatever works is fine. There are plenty of options out there for all of you to have this assignment done. So you're going to graph the system on the coordinate plane provided and then identify the solution at the bottom. Okay? Once you do that, there's an exit ticket. Now I wanted to just go over this because I feel like it looks a little